Hello everyone, welcome back to the another session in Principles of Programming Languages. We'll continue to see about concurrency. So we end up the last video with the methods of synchronization. We were come across with three kind of methods to provide the synchronization. The first is what? Semaphores, monitors, message passing. So now this video is going to talk about the rest of three methods, which are semaphores, monitors, message passing. Now let's understand about this. So the thing is what? A semaphore is basically introduced by Dijkstra's. Dijkstra's actually a very familiar author who has invented many contributions, many things to the computer science world. So semaphore is also from his account. So basically a simple mechanism is to provide a synchronization of task through mutual exclusive access to shared data structure is semaphore. So a semaphore is a data structure consisting of a counter and queue for storing task descriptors. So it's basically a counter. See, let's understand about the counter variable. So when counter variable is 0, that we say that none of the processor is under the execution. If counter value is 1, we say some processor is under the execution. So if it is a computation synchronization or cooperation synchronization, whatsoever the task is, it will be weighed by looking into the semaphore descriptor value. So that was the idea behind of it. Now, task descriptor is a data structure that stores information about execution state of a task. So, whichever process is under execution, semaphore counter variable value will get updated. Semaphores can be used to implement guards on the code that access shared data structure. Semaphores have only two operations. One is wait, the other one is release. So, these are what two operations what basically we'll find in semaphores. Now, so let's see about an example, cooperation synchronization with semaphore. Example is a shared buffer. If that buffer is implemented as an ADT, abstract data type of particular language, with the operations deposit and fetch as the only ways to access the buffer. So use two semaphores for cooperation, empty spots and full spots. The semaphore counters are used to store the numbers of empty spots and full spots in the buffer. So by maintaining the values of empty spots and full spots, now synchronization is being provided among the tasks what are ready for execution. Now semaphores wait and release operations are follows. Wait a semaphore. Now look at this. So the way how we will update the counter values, wait a semaphore. If a semaphore counter value is greater than 0, then we decrement the semaphore counter. Else, put the caller in the semaphore queue, attempt to transfer control to a ready task. If the task ready queue is empty, if deadlock occurs, end. Now, release operation is what? When you are releasing a semaphore, if a semaphore queue is empty, then increment semaphore counter. That's what, right? So, when it is released, when semaphore is releasing a task, now we can fill that semaphore value with the other task commencement. So, this is what release and wait operations, how it performs in the processing unit to execute the things. Now, let's see about monitors. So, basically monitor is supported by the programming languages which are Ada, Java and C#. Used to avoid some of the problems of semaphores. The idea is encapsulate the shared data and its operations to restrict access. A monitor is an abstract data type for a shared data. Provides competition synchronization without semaphore. Concept is what? All synchronization operations on shared data to gathered into a single program unit, named these structures as monitors. So this is what without semaphore we do the synchronization. Now shared data is resident in the monitor. Programmer need not synchronize access to shared buffer. All access resident in the monitor. Will not use any kind of semaphore to update the counter values. Without semaphores, we will do the process in the monitor. Monitor implementation guarantee synchronized access by allowing only one access at a time. Calls to monitor procedures are implicitly blocked and queued if the monitor is busy at the time of the call. So monitor will monitor the performance of task. When task 1 is engaged in the processing or execution part, the other task, the system which will monitor the task which is under the execution process. So if it is if it is doing some execution part, the other thing will be waited or queue. And now let's see about this cooperation synchronization with the help of monitor. So now let's understand that a program is consisting of 4 processes. Now what the duty of monitor is, monitor may basically have 2 things: inserting the process and removing the process. So inserting the process is what? When the process whatever we have in the one program. So sub 1 is one process in the same program, sub 2 is the process, sub 3 and sub 4. Now sub 1 is entered into the monitor. Now after you complete the procedure of execution part of sub 1, we remove the sub 1 and we'll take sub 3 or sub 2 or whichever is ready in the queue. So this is what without semaphore we'll do with the help of monitor. Now evaluation of monitors are what? A better way to provide competition synchronization than or semaphores. Semaphores can be used to implement monitors. Monitors can be used to implement semaphores. Support for cooperation synchronization is very similar as with semaphores, so it has the same problem. Now, we can also see about message passing, how message passing will be helpful to have synchronization, task synchronization. Suppose task A and B are both in execution. A wishes to send a message to B. Tasks are often busy. When busy, they cannot be interrupted by other unit. Messages usually cause associated processing in the receiver. So synchronous message passing is what? It allows a task to specify to other task when it is ready to receive messages. A task can suspend its execution at any point when it idle or needs information from the other units. So these are the common steps to done the message passing work. So to support concurrent task with message passing, a language is required. A linguistic mechanism to allow a task to indicate when it is willing to accept a message. So a way to remember who is waiting to have its messages. Some fair way of choosing the next message if a task receives a lot of message from the other task. So when a sender task message is accepted by a receiver task, the actual message transmission is called as range US. It is important, range US. So during range US, information is transmitted in either or both the directions. So in general, so message passing is what? So when 2 tasks are in the execution part, so one task wanted to send the message that I am in the queue list, that I wanted to take the execution part or something, then we cannot interrupt the execution part of the other task. So we will take a range US. That range US is what? Sender task message is accepted by a receiver task, the actual message will get transmitted. This is the state of range US we used to say. Now, so let's talk about Java threads. Now thread is what? Actually a process, a task which will get executed. So now we were discussed about threads are being supported, the task is being supported by the languages Java and C#, right? Now let's see about Java threads. The concurrent units in Java are methods named run. A run method code can be in concurrent execution with other such methods and with the main method. So the process in which the run methods execute is called as a thread. So thread is what? Thread is the process where we were running the run methods. Run is what? It's a concurrent unit of a Java. Now Java's threads are lightweight task. So lightweight task is what? Will execute in the same memory space. It means they all run in the same address space. 2 ways to define run method. Override run method of thread class in subclass. Implement runnable interface which provides abstract run method. So subclass must provide body for the run method. True, right? Now, so just take class myThread extends thread, public void run. So now runnable method, we will just creating the object for this thread and we were executing the thread. So thread is what? It's just like a lightweight process to execute. Now let's see how C# threads also being executed. So it is what? These Java threads execution scenario. that we will take a new thread and new thread will start and it will get run. So runnable is what? We will just execute this, and running is what? So you can identify the difference in between runnable and running. So basically runnable is what? The task which has been blocked by some other task, again we will be resuming it, right? So that is what we say it is runnable task, and once runnable task is done, we just stop the task or the task will get dead. And after this thing, we will go for running status and then we will go for a blocked status. So this is what ideal thread, we just have a state transition diagram for runnable threads. So this is what how Java will take the execution part of threads. Now let's see about how C# threads will be executed. Basically C# threads are what? Loosely based on Java, but there are significant difference basically from Java threads. The operations what C# thread will do is, any method can run in its own thread. A thread is created by creating a thread object. Creating a thread doesn't start its concurrent execution. It must be requested through the start method. We do have a start method. There in the Java we say that threads are with the run method. In C# we say it is a start method. A thread can be made to wait for another thread to finish with the join. A thread can be suspended with the sleep. A thread can be terminated with the abort. The same things were also there in the Java that we were seen with the name of block, wait, suspend, right? So the names are quite different here, and even the way you are using the run method in the Java and start method in the C# is also having a difference, slight difference in between of these two, that we'll see about the C# threads. Now, so let's understand there are three ways to synchronize C# threads. The three ways are what? The interlocked class, lock statement and monitor class. These are what three ways of different type of way, these are the ways to synchronize C# threads. So thread is what? A task which has to be get executed. C# will support these synchronization with three levels or with three ways. Those three ways are interlocked class, used when the only operations that need to be synchronized are incrementing or decrementing of an integer. So interlocked class is what? Will increment and will decrement of an integer when the only operations that need to be synchronized. The lock statement is what? Use it to mark a critical section of code in a thread or in a process, so that we will lock it. And the lock statement is compiled into a monitor. So lock is shorthand for a monitor. The monitor class is what? It provides 5 methods that can be used to provide more sophisticated synchronization. So these are what? Again the methods are what? So we'll begin the method that start method, new. If it is a new process, it is a new method, run, and runnable, block, dead. This is what thread has been initiated in the language until the process has been taken into the programming language. Once it is done, we just block it, we just suspend it, we abort it, right? So this is what the way of executing threads in Java and C#. So that's it. It is about concurrency and threads. Thank you all.